coming out. We got a great presentation tonight. It should be pretty exciting. And what else do we want to say? Yes, August, IoT, Xamarin, good stuff. And so I want to say a big thanks to ILM for sponsor and host. Big round of applause for those guys. And I guess we'll let you speak.
Sure.
Amy from ILM.
Hi everybody, I'm Amy from ILM. We're so happy that you guys could come here tonight. We're happy to host. I just wanted to say really briefly, we have the Minnesota Developers Conference coming up on September 27th. It's a full day conference. Keynote speaker is Scott Hanselman. We also have some local speakers and some more national speakers. Tickets are still available, but they do sell out every year, so don't wait till the end. I think we have about 110 tickets left, so out of 500, so be sure to get your tickets. And also, we are selling sponsorships for the MDC, so if you guys are looking to hire some developers or anything like that, you want to have a booth, feel free to contact me. So thanks.
Great, thanks so
Thank
much.
you. All right, quick current events. We want to get the show on the road. The one thing that I know I was talking to these guys about earlier, Xamarin University, they just announced on their blog that they've made some changes to the Xamarin University subscription. So before, it was $2,000 for your first subscription and then $1,500 for your recertification. I believe the cost is staying the same, but you no longer have to take the test the second time and third time. As long as you stay current with your subscription and take the required classes, your certification stays current. It's kind of a big change in how they're doing the university program, and I think it's pretty sweet. And probably the right way to go. So that's some of the news item I have. If anybody has anything else, please feel free to share. Otherwise, we'll do quick intros.
Sure.
Quick intros.
I'm Scott Colestock, also a contract developer. I spent a long time working with these gentlemen on the Polaris Ride Command app. These days focused a little bit more on vehicle integration, but yeah, Xamarin is near and dear to my heart. So thanks for coming today. We've got some cool things to walk through, I think. I wanted to start off showing you oh, we never got to this slide, but yes, Xamarin, ILM, better together. I wanted to show off really my 8th grade science project, or at least that's kind of what it feels like when you see it. Is anybody here really deep into Arduino and Raspberry Pi and that kind of thing? Few people, okay. I just apologize to you because this looks pretty rough. I'll just warn you, but it's useful in terms of the talk we're going to do this evening. What you see here is a Raspberry Pi 3 with a Grove Pi shield attached to the top so that I can attach some kind of some off-the-shelf sensors. That's what you see kind of at the top of your screen. And then I've got a digital temperature and humidity sensor. That's the little guy with the blue. And a couple LEDs, a red LED and a green LED, and then a little speaker. And then finally an LCD screen that we can control. And that, just before we even get any further, let me just kind of show you a little bit about what this guy does, because we're going to keep on coming back to it. I'm just going to fire up a simple version. Can't type. There we go. Just kind of show you what this thing is about. So what it's about is that when the threshold temperature is crossed, it starts making a lot of racket. So let me fix that first, because it says that it's 80 degrees in here. And since we all are quite sure that the buzzer's capable of working, we'll go ahead and unplug that, right? And just for purposes of seeing that transition here quick, right now I have this notion of a threshold temperature, and I'm going to go ahead and change that threshold temperature to something a little bit higher than the reported temperature in this room. I don't know if it's actually 80 degrees in this room. I think the off-the-shelf kind of consumer-grade digital temperature and humidity sensor is not super accurate, but that's okay. So I've changed the threshold to 81 degrees. Let's go ahead and run this again. And what you see is that the way this little device works, again, just a Raspberry Pi with some off-the-shelf sensors, is that when the temperature is below a set threshold, then you get a, oops, sorry, back here. When the temperature is below a set threshold, you get a green LED, you get the green LCD with temperature and humidity reporting, right? And then the way this device works is that if I go above the threshold, step over here, let's breathe on this. Hope I don't want to do this for long, it's kind of embarrassing, but. It's like a breathalyzer, only different. It's
It would have triggered already if it was a breathalyzer.
There we go. Now it says, hey, it's too hot in here. I brought it up to 82.4 degrees. I get the blinking red light. I would also get the beeping if I hadn't unplugged that to keep us from dealing with that. But that's essentially what this device does. It's all about just a kind of a closed loop temperature monitor that squawks at you when you get above a threshold temperature. And that's kind of what we're going to walk through this evening, is how we can make this device smarter. So this is just a basic device, but how can we use MQTT and a backend IoT service and some cloud connectivity, and then integration with a mobile app where we can create kind of a companion experience for this device. Most people, if you're all into home automation, that kind of thing, you're kind of familiar with this, or maybe it's your car or what have you, you're familiar with this idea that, hey, my thermostat has an app, and my car has an app, and my Wemo lights have an app, and my Hue Philips LCD light, I don't own any of those, but they look darn cool. My Philips Hue lights have an app. You know, that's kind of the model that people are used to at this point, is that there's a device that I want to reach out and remotely control, and that's what we're going to be talking about this evening, is just kind of that concept. You know, build it up from the ground level. What would you do if you wanted to make that kind of thing happen? Does that make sense? So what's funny about this temperature sensor is that it's actually fairly easy to heat up, but what you'll see is that it takes a long time for it to cool back down, but it'll turn back to green here in a little bit. So, in the meantime,
You need to bolt it to a large metal heatsink.
beg your pardon?
Bolt it to a large metal heatsink.
That would work better. Yeah, the other thing I was doing last night is I was putting a beer bottle on top of the glue sensor. It came out of the fridge, yeah. Of course, if you keep on drinking the beverage, then it's cold effect. So, yeah. Okay, so I just want to talk a little bit about the IoT market generally, just to kind of level set. This is a picture I've seen floating around. I can't claim credit for it, but this idea that if you think about the concept of a phone number, we've kind of gone from one in every town to one in every store, right? And then all of a sudden one in every home, to one in every hand, and now more recently with the cost of data lines and cellular hardware plummeting, you're really getting to the point where you're going to have one in everything, and you're pretty darn close to that already. A good cellular module is down in the $15 to $20 range at this point. Data plans can be had in the $2 to $3 per month range, depending upon the amount of data you're trying to move around. And so that creates just an incredible amount of opportunity. There's a lot of companies that I think have been in the sensor business or the machine-to-machine business for a long time. We're kind of taken by surprise that in 2015 anyway, there was like this whole new hype cycle around IoT. They're like, wait a minute, we've been doing this forever. What do you mean that IoT is this new thing? But as the cost of data plans and the cost for connectivity drops, there's just a whole lot more interesting opportunities that get revealed. And those efficiencies of more visibility, whether that's visibility into a supply chain or into a manufacturing floor or into a vehicle, those are being appreciated in more and more sectors of the economy. And then all of a sudden that creates a kind of an imperative for other people to catch up. And so the market is just exploding in this area. This is a picture of the, take a note here, of the Shamala River in Karnataka in India. And I thought it was interesting because after a drought, a long period of drought, all of a sudden these interesting archaeological findings started becoming visible, right? And so people were amazed that all of this stuff was under the river and now is visible. And markets behave like that a lot of times. Sometimes as the cost drains out of a particular market, like cellular chips and data plans and that kind of thing, all of a sudden there's these like, well, wow, now there's a whole other set of opportunities that are accessible if data plans are going to be $2 or $3 a pop and cellular modules are going to be 10 or 15. And so that's what you're seeing happen right now. It's why these giant, million plus deployments of smart meters are happening and that kind of thing is because of that change in the market dynamic. So a quick level set on the market. IoT, or sometimes people talk about M2M, machine to machine, is defined as the exchange of data between devices across a network for monitoring and control. Pretty straightforward. And the ingredients that you need to make that happen are sensors like these, or sensors that are a heck of a lot more robust than these, but you need sensors to capture asset status and event data. You need a device that can aggregate and transmit that captured data. So you don't just need the sensors, but you need at least some edge intelligence to be able to read those sensors and package up the data in an interesting way. You need a communications network. Sometimes that's a whole bunch of sensors that are talking to a gateway device, which in turn is relaying over a corporate Wi-Fi network, or that gateway device might be responsible for relaying over cellular network, or sometimes the devices are connected with their own cellular connectivity, which is going to happen more and more, of course, right? And then you need a back-end software system that's going to translate and analyze and act on that data. Those are the pieces that come together to really make IoT work out. There's three big segments that have come up in IoT in the market. There's device management, where it's all about reaching out and being able to configure devices, provision devices, troubleshoot devices, monitor devices. There's network management, which is about provisioning data services, activating and deactivating wireless plans, monitoring performance and usage metrics, like, hey, how much data is this thing actually consuming? Spend optimization, but also just the networking environment. So like sometimes I want private IPs, sometimes I want static IPs, sometimes I want what's called a private APN in the cellular world, sometimes I want VPNs out to the edge. So that's all the pieces that fall inside of network management. Often network management is provided by the wireless carrier, but sometimes it's the visible part of what you'll hear referred to as an MVNO, or a mobile virtual network operator. So there are multiple companies out there that will buy airtime in bulk from Verizon and AT&T and Sprint, and then they'll repackage it and resell it in chunks that are appropriate for an IoT application, right? Because AT&T generally doesn't want to sell you a 2 megabytes per month data plan. Actually, I shouldn't say that. I'm sure they'd be happy to do that because they want into the IoT market as well. But virtual network operators essentially repackage and offer network management. But then the final piece after device management and network management is really application enablement. And you might say, well, it feels like this could just be the same back-end applications we've always been writing. Why wouldn't this be web services? Why wouldn't these just be the same patterns we've used for back-end services in the past? And it really comes down to wanting to have, often at least, an MQTT broker. We're going to talk a fair bit about MQTT that can support publish and subscribe. MQTT turns out to be a lot lighter than HTTP and generally results in less time and power per server interaction, which is interesting for IoT. When you're trying to deal with publish my current state as a primary use case, like that's mostly what IoT is the device saying, hey, here's my current state right now. Then it turns out that there's some different things that you want for that back-end application server that are a little different than you might want from a web server. There's some things you can do if you assume that that's the primary use case. Often you want ad hoc exploration and visualization of the data. So if I've got all these devices that are reporting their current state, I kind of want to be able to walk up to the platform and just play with that data a little bit in ways that, like, say, a web server that was exposing web services wouldn't necessarily be geared up for. And when you know you're doing mostly telemetry, which is publication of just these semi-uniform data sets, then a lot of declarative techniques become interesting. And so you'll see this whole notion of being able to do SQL over streams. So like things like Amazon Kinesis support doing SQL across the streaming data that you're going to get in the future, right? I like to think of it as SQL across the future. So like something like this is just an excerpt from that I took when I was playing with Amazon's IoT platform. But I'm basically saying, hey, I want to insert into this DynamoDB table all of the records where the reported oil temperature in Fahrenheit is more than 200. And I can set that up declaratively on the data that's going to arrive in the future, essentially. And the ability to create those kinds of declarative operations is also an interesting feature of IoT backends that is sort of a new piece, a new piece of the pie. So the complexity across device management and network management and application enablement, that's created a market demand to get them from a single vendor. You'd like to have one throat to choke in a lot of these cases. And so there's been a lot of merger and acquisition activity to try to make that happen. Certainly AT&T and Verizon would like to be that person for you, but there's a lot of other companies too that will do this. We've been working a lot with a company called Telit, but there are Sierra Wireless and ThingWorks and on and on and on.
Project
Everything.
Fi.
What's that?
Project Fi.
I still didn't hear.
Project Fi.
Project Fi, okay. I mean, it's a big market. The IoT market is exploding. Amazon has an IoT backend, but and it's interesting, but they don't offer really device management or network management. They just have the platform. So that's kind of what's going on with the IoT space generally. But let's talk about MQTT. Let's get over to developer topics. Any questions about the IoT market or other observations that other people want to share at all? Okay. So with that level set in mind, MQTT is a binary client-server protocol. It's a pub-sub messaging transport protocol. It has been standardized, and it uses a lot of the characteristics of the TCP transport. Like it needs the reliability of TCP, so you need a working TCP stack to make it work. Generally, it's traveling over port 8883 if you're doing it securely. And it's used in, actually, the original acronym, how many people are old enough to have worked with WebSphere, MQ, or MQ series? Okay, I'm glad I'm not the only one. So the original acronym expanded out to Message Queue Telematics Transport, and it was invented by IBM, and then got later standardized. It no longer, now it's not really an acronym anymore, it just is. Yeah, this came out of IBM probably in the late 80s. It gets used in a lot of automotive markets, a lot of smart home applications, a lot of energy monitoring, that kind of thing. It implements a brokered publish subscribe pattern. So devices are publishing up to a centralized broker, and then other devices or applications can subscribe to what they, to what's occurring on that server, and you get this brokered publish subscribe pattern. And as I mentioned before, you can save. It's actually pretty dramatic in some cases, in terms of power and time and data over straight HTTP. One of the reasons it's a nailed up TCP connection. You're not renegotiating security or renegotiating a connection each time. What's on the wire tends to be a lot more compact. Even just eliminating HTTP headers turns out to actually be a fair bit of savings depending upon what else is going to be in the payload. So it's an interesting protocol for that reason. If you were to look at what was on the wire, you'd find that there is like a fixed header that defines some message types that I've got listed out below here. Then you got a variable header that references the topic name and the message ID, and then a payload, which often is JSON, doesn't have to be. The standard doesn't say it has to be JSON, but in practice it winds up being JSON most of the time. The kinds of operations, if you think of like over an HTTP, we've got get, put, post, delete, and some others that people don't use, like head and option and that kind of thing. Here you've got kind of a different set. You've got verbs to connect and acknowledge a connect, verbs to publish and acknowledge a publish, verb to subscribe and to acknowledge that, unsubscribe, and then some heartbeat messages to assure communication, and then a disconnect. So pretty simple protocol, pretty straightforward. The publish and the subscriber, of course, don't need to know about each other. You can publish to a topic that just other interested parties subscribe to, but they don't need to actually be on the network at the same time necessarily, although, as you'll see later, that gets a little fuzzy. But certainly they don't need, the subscriber doesn't need to know who's publishing the data. It's pub-sub in that sense. The topic definitions just use a path-like structure, like sum/test/topic or what have you. And topics are just created dynamically, so you don't have to, it's not like a message queuing system where you've got to walk up and manually create a topic, or a queue in the case of message queuing. You can just, as soon as you publish to a topic, it is. That's enough to have created it. Subscribers can subscribe with wildcards, either single or multi-level wildcards. So it's very flexible in terms of on the subscribing side as well. Just as with the web, even if you're a REST guy, there are differences of opinion about how to organize URI and path space. Exact same thing is happening with MQTT. There's a lot of differences of opinion about how you should structure topics, what you should put in the payload versus what semantics you should try to put into the topic path. all of that is not consistent from MQTT, from IoT backend to IoT backend. So there's a lot of, the way that you use an MQTT broker winds up being extremely application dependent. If you were to walk up to Amazon's broker or Telit's broker or Sierra Wireless's broker, you'd see quite different usages of MQTT just in terms of the way they use the topics and whatnot. And MQTT is even at a little bit more of a disadvantage than REST, I would argue, because there's just the one publish verb. And so, at least HTTP was able to say, hey, we've got get, put, post, delete. Let's attach some semantics around those and have this notion of a standard interface with REST. MQTT doesn't really have that going for it because of just the single publish verb. There's this notion of quality of service levels in MQTT. I won't dive too much into this, but essentially the two that you'll find in practice are at most once delivery, which sort of means that your data might get there, right? And at least once delivery. Those are the two that in practice get used the most. There's a couple brokers that claim to be able to do exactly once delivery. That's pretty tough in practice. If you've ever done a lot of distributed programming, you know that the kinds of things that are required to be able to offer that guarantee are significant, tough to do over the internet. So most brokers don't try to implement that. Most of the time it's 0 or 1. 1, of course, requires acknowledgments. 0 does not, and it turns out that 0 is actually pretty interesting for most telemetry applications because if it's somewhat lossy, that's really not a big deal. Like if you miss one publication of state, if I miss one of these temperatures, it's not a big deal. Another one's coming, right? So that turns out that quality of service level 0 can get used quite a bit. Let me just dive in and just show you a brief demo of. Let me just say this too. Publishers send with a given quality of service. Subscribers subscribe with a given quality of service. So from a given publisher to a given subscriber, the net quality of service is the lower of the two, right? I can publish with 1 all day long, but if subscribers are subscribing with 0, then obviously the net quality of service between those two endpoints is 0. That trips people up sometimes. Let me just show you.
Does it have, does it support like real time, like UDP or anything like that?
You will see in a bit that you can do MQTT over UDP. It doesn't get done over very often. It almost always happens over TCP, but the real timeness is pretty darn good. The real time, for most IoT applications, you'd feel pretty good about it. So I just have a generic tool here. I just want to show you briefly from the App Store called the MQTT tool, and that's running on my phone on the right hand side. Left-hand side, I have a generic OS X MQTT client, right? If I were to look at the configuration parameters, on the OS X side, I am connecting to a publicly accessible open broker at eclipse.org, m2m.eclipse.org. I'm even attaching insecurely over 1883. The secure port is 8883, and you can see I don't have SSL set up. But I'm going to go ahead and connect to that broker over here. And then over here, I'm going to connect to the same broker. So now he says he's connected, right? Then I'm going to go over to, it's so funny, I'm so tempted to click on this screencast of my phone, but of course that doesn't work. I'm going to go ahead and subscribe to a topic Scott/pound, which is the multi-level wildcard, right? So I'll go ahead and click on subscribe. And then I'm going to go ahead and publish this message to Scott/MNEM1. And if I publish here, you can see that appears over on my other device. Publish again. I publish to a different topic, and because I'm published to a wildcard, or I'm subscribed to a wildcard, sorry, on the right-hand side, that'll work. Over here, I'm going to go ahead and subscribe to Scott/2, and then on my phone, I'm going to go ahead and publish to Scott/2, and you can see that came through. So, real basic, nothing fancy, just a kind of a basic demo of how those work. Even if at the moment I can't really show you this, but if my phone because I've got my phone plugged into my Mac, so it's picking up my Mac's connectivity. But an interesting experiment to do is to have put your phone on just cellular data, right? And of course your laptop on just corporate Wi-Fi, and to play with that combination, and it's actually still pretty darn good. You just get a sense for what the latencies are like and that kind of thing. So that's MQTT in a nutshell. Go back here.
Scott,
Yes.
is that broker just one to play around with?
Just
or
one to
is it-
play around. There's a
Okay.
few publicly open brokers that you can just play with. You certainly wouldn't want to put any confidential data on them, and you certainly wouldn't want to build anything on production. But there's if you go look for publicly available brokers, you'll see that there's quite a few that people maintain. There's a company called Hive that makes an enterprise-grade MQTT broker, and they like to have theirs up for marketing purposes.
I was surprised about the ports. I thought those were just standard 80 and 443.
Well, 80 and 443 are reserved for HTTP, for secure and unsecure, or for 80 for HTTP and 443 for HTTPS. So because MQTT is a different protocol, it's required to use a different port by internet convention. But it's a good point that port number 8883 is not very firewall friendly. And so what some people will do, get down to where it was here, sorry. What some people will do is they will tunnel MQTT over WebSockets. And most brokers have the ability to do that. So WebSockets is a protocol that runs over 443, but gives you a TCP connection. It's a internet standard now at this point, right? Somebody nod their head. WebSockets is the standard. It took a long time to get there, but I believe it's a standard. And so you can actually tunnel MQTT or other TCP traffic or other TCP-based protocols over WebSockets. Most brokers support that. The C# library that you'll see that we are using later does not. It's kind of sad. So yeah, to be an app that would work inside of a corporate environment, you'd really want to do MQTT tunneled over WebSockets. Because most of the time, if you're like in here, we're good because this is there's not overly restricted people running the network here, but if you were in a stand like a Target or something like, wow, I shouldn't even name this company, sorry. If you were in a standard corporate environment, then all of those ports would be closed. Can you read that, God? Okay, so.
But normally if you're doing TCP, it's a persistent connection then, the MQTT connection?
Yes.
You open up the TCP and then as long as you're there?
Yes.
Is that where the quality assurance and message delivery goes? So if I disconnect, when I resubscribe, are there messages that went to that topic while I was gone, or?
No, with QoS 1, it is possible. There are many brokers who implement the notion of we didn't really get into it, but there's a notion of a session. Well, I guess it's here in this third bullet here. If you connect with what's called a persistent session, you're basically saying, I want to keep all of my past subscriptions, and I want you to deliver any of my missed quality of service 1 and 2 messages.
So if there's a hiccup at that QoS level, you'll still get the other stuff in the free
Yes,
It's not like-
exactly right. Now, some brokers don't try to implement that feature, but it's in the spec.
It's an expensive feature, but yeah.
Yeah, exactly. There's some other expensive features that are interesting. Last will and testament messages, which basically says, hey, Mr. Broker, I'm going to give you a message at connection time that's going to be delivered if I don't disconnect gracefully. Kind of interesting. And then this notion of retained messages where you could say, I'm going to, hey broker, I'm going to give you a message that represents kind of last known good state, so that can be delivered to anybody who in the future subscribes to this topic. So there's some kind of interesting features off to the side, but what we've talked about so far is kind of the main guts that you'll see implemented on most brokers. Not everybody's a fan of MQTT. Who remembers Clemens Vaster as an old hand at Microsoft who was responsible for like the Azure Service Bus, that kind of thing? Okay, I'm showing my age again. So he's not a fan. There are some issues with the protocol in terms of its extensibility. There's some strange decisions that are made about how they choose to conserve bytes that really don't take into account what you're going to spend on a TCP header anyway. So there's some strange decisions there. There's some strange ways of communicating version info that are kind of wasteful. There's nothing said about payload encoding, which you could argue as a plus or a minus. And there's no way to negotiate content. You just need to know that it's JSON or it's what have you. Unlike HTTP, which has a pretty rich model for negotiating content types, right? Nothing's like that in MQTT. Messages are delivered immediately if you're subscribed to a topic. Like if you subscribe to a topic, messages are coming, and so it's up to you to implement flow control, right? So if you are not prepared to deal with receiving messages right now, you're still gonna deal with them. And so there's some weaknesses, but well, I look at all that, I think, you know what, there's protocols with weaknesses that thrive all the time, and I think MQTT will do likewise. I mean, there's a lot of protocols that you look at and you say, wow, it's got a lot of issues, but they still thrive, right? So I think MQTT will do just fine, and frankly, it's been around already for 20 plus years, so.
In the 80s, it might have originally been written for some kind of token ring.
That could be, could be.
Being the idea.
Let's come back to IoT backend. So we talked about MQTT. An IoT backend, like Amazon's IoT backend or ThingWorks or name your favorite, its job is to ingest data at really large scale using a variety of connection protocols, often MQTT, but sometimes, sometimes others. They provide the ability to interact with the ingested data and the connected things, and by interact, I mean both, usually there's some sort of admin interface where you can reach in, touch the data a little bit, do some ad hoc queries, but also kind of at the API layer. They give you the ability to respond to data under various conditions, sometimes creating rules engines and that kind of thing around the data that you can apply sort of administratively without having to write more code. Let's contrast two players just because that's kind of interesting. Different IoT backends bring different levels of formality to the definition of the things. Now, for some reason in IoT, everybody persists in using the word thing. If you're a developer, you probably prefer the word classes and objects. You probably think of it as that, right? But IoT uses the word thing. Amazon limits the thing definition to really just 3 key value pairs, and then a JSON body that it cares nothing about. It's like, you get 3 key value pairs, and then a blob of JSON that you can control. The platform really doesn't have any insights into the structure of that, really doesn't allow you to do things based on the content of it, except when you start writing the SQL-based rules that I showed you earlier. Those SQL-based rules have the ability to drive down into the JSON, but the basic administrative backend really doesn't care about the structure of your object at all. If I were to go and just take a look at, this is Amazon's IoT admin interface. I've got this object that I call a light bulb, and it has color and volume, but there's no. It's tough to show you. When you see the other interface, you'll see what I'm saying. There is no place in here where you can say, I want to edit the definition of a light bulb. I want to go and describe, I want to model that. I want to describe the 5 or 6 attributes that it has. I want to assign some data types to those, some expected data types anyway. None of that is present in Amazon's solution. They just say, that's an exercise left to the reader. You are going to manage the schema of your IoT object, and we don't really care about it so much. That's kind of at one end. The Tellit, which is a company that we've been working with recently, that does, they do device management, network management, and application enablement. Their thing definitions are really analogous to classes. You've got attributes, which are strings. You've got properties, which are ints or floats. You've got what they call alarms, which is kind of a strange name. They're really sort of enumerations, like buckets of states. So you can have you can say, I want something that's low or high, I want something that's on or off, or I want something that's freezing, warm, burning, that kind of thing. They allow you to define methods, where you can say, I want to define the structure of a method, and without saying anything about its implementation, just saying that, hey, this object exposes the ability to do this, and it's parameterized in these ways, and I'm expecting it to return values that adhere to these data types. And then they also have the notion of saying, hey, if you want to be able to just add attributes and properties on the fly, you can do that too. They call those auto-defined. So they give you a pretty rich schema for doing this. Which approach is better? I'm not sure. I don't have enough runtime experience with either platform to say how it would play out over, say, a multi-year project. So far, I think I like the richer definition better. It certainly feels like you can get more done in the short run with being able to define schema in a richer way. And then the things, of course, are analogous to objects, right? They're instances of the thing definitions. So that's kind of the way Amazon does it versus Telit does it. You could find, if you went and visited 4 more IoT brokers, or excuse me, IoT backends, you'd see some different things going on. In addition, the way that they each treat topics and the payloads associated with the messages are quite different. So in Amazon, they have this notion of a shadow service, and the things report their state to a topic that looks like this, where you say, hey, some thing name, some identifier /shadow /update, and then you use a little bit of JSON to say, I'm reporting that. And other objects that want to interact with that thing, like they want to reach out and turn the light off, they simply send the exact same JSON body with what they would like, the state they'd like the thing to be in, and then they say that's the state that's desired. So it's very, very loose. With Telit, they say, hey, you know what? We're going to use this standard called TR-50, and it's basically a way of representing these operations more formally. I don't want to say strongly typed because it's still JSON, but it's a way of being a lot more explicit about what you want to do. So two very different approaches, both to how you model things and how you interact with those things over MQTT. They're quite different, even though the protocol is the same, and they both have MQTT brokers. That's really just like saying they both have web servers, just like you would expect it to be different from one web service to another. It's certainly different here as well. So with that in mind, let's go back to this simple IoT device that I showed at the beginning. We've got the Raspberry Pi, we've got the Grove sensor kit with some off-the-shelf sensors, and we've got this really simple Python app that I'm going to show you to measure temperature and to alert us if it goes above a threshold. Let's go ahead and just take a look at that in a little bit more detail. Let's see here. So this guy's still running. It says 80.6 degrees, and you can see there it says 80.6 degrees there. Let's go ahead and take a look at the simple implementation here. If I bring this up, this is written in Python just because there's good library support for this particular set of sensors in Python. It gets trickier in C# to find good libraries for interacting with devices. Maybe that'll change with, anybody played with Microsoft's Windows IoT? They have this super small scale operating system they call Windows IoT that will run right off of a micro SD card, just like Raspbian. I haven't played with it much, but it could be that as that matures, that then you'll see more C# libraries for connected sensors and whatnot. At the moment, Python's a really good bet. So this is a very straightforward little app that's driving what you see on the screen. I'll try not to point at my phone. That's driving this interaction here. So all I have here is a class that I call temperature monitor. And I'm initializing a few fields that I want to care about, like my temperature, my humidity, an action message that gets displayed when I cross my threshold, and the threshold itself. And then I have a little method called readData that uses the Python library for interacting with that digital humidity and temperature sensor to read back temperature and humidity and to tuck that away into member variables of the object. Okay. And then in the main loop, it's pretty darn straightforward. I set my initial state, the backlight of the LCD I want to be green. I want to turn the green LED on, the red LED off, and heaven forbid if I've left that buzzer running because of a fault, I want to turn that off as well, right? So that gets my initial state going. And then I could just have a while true here, but when I'm using this with a cellular modem, I'd rather not have it run forever. So in an essentially infinite loop, I read the data, which was this method up here where I'm just grabbing these values. I read the data, and then based on whether or not I'm over the threshold or under the threshold, I'll do two different things. If I'm over the threshold, I'll turn the green LED off. I'll set the red background on. I'll set that text message, and then I'll start blinking the LED. Otherwise, I'll go ahead and turn the green LED on, get the green LCD screen going, and just output a simple display of temperature and humidity. So again, if I come over here and give this a warm up. Here we go. Trip that, so you can say it says it's too hot in here, 82.4 degrees. That's because it's above my threshold temperature. This is pretty darn simple, right? It's like very straightforward things. People who actually do Raspberry Pi or Arduino stuff would find this to be about kind of the simplest possible use case. Let's talk about what it would take to get this guy connected to a cloud over MQTT, which is kind of part one of where we want to go. So if I steer over to the cloud version of this little demo, the temperature monitor class that I showed you before is identical, so I've got that collapsed. The user callback thing I'll talk about in a second. Let's just talk about how the main loop is different. Obviously, I've got some authentication things that are represented up here at the top, but for the most part, so far, identical. But then, at the point that I am getting started, I'm going to go ahead and issue MQTT Connect. So where's that coming from? Well, there's really one good authoritative place to get MQTT implementations for different languages, and that's eclipse.org/PAHO. I'm not sure how it's pronounced, but PAHO. And you'll find that there's C libraries, some lighter libraries for embedded C and C++ applications, Java, JavaScript, Python, Go, and C# are all represented there. So this is really, at least today, this is where all the implementations are, is within this project heading. So the first thing we're doing here is we are connecting. This library that I'm calling, though, is actually a wrapper supplied by the IoT backend that we're using. We're using Talent's IoT backend. They provide a little Python wrapper to be able to assist you in preparing the payloads, right? So it's one thing to connect. It's another thing to actually prepare payloads that tell the cloud about something. So this connect, I'm sure, is a pretty light wrapper. But further down here, after we have read our data, read our temperature, we want to publish what it is that we found, the temperature and humidity, using this method called property publish. Now, that's obviously not an MQTT thing. That is a wrapper that the vendor is providing, the IoT backend is providing. And it's pretty darn straightforward. If I drill into that guy and I look at the JSON that he's creating, this is just their source code. It's creating a JSON blob here that you can see looks pretty straightforward. I've got some JSON that says, hey, I've got a command, I'm publishing a property, I've got the thing that I'm interacting with, a key that represents this particular temperature monitor, and then I have a key and a value for representing the temperature. So the wrapper library that the IoT backend has given me for dealing with MQTT in Python knows about, sorry, wrong one, is giving me this wrapper so that I can publish changes to properties here. That's all that's going on, very simple. The other thing that I'm doing, so let's go, you know what, enough said, let's go ahead and see what that looks like. So I'm going to go ahead and this is the simple one. So we were running IoT demo simple, right? It's the bottom of the screen. Demo cloud.
Does Talent have all their API calls in that Python wrapper?
Yes, for the most part. I don't know of any that they don't offhand. So I'm running, the device is going to behave basically the same because we just added the cloud connectivity. What I'm going to do is go over here to Tellet's web UI, and I'm going to refresh this page where I'm actually, this particular temperature monitor that we've got sitting on the table here is identified to the back end as just RASP IoT-1, so that's what we're looking at. And there's a couple things that you can see if I drill into the temperature. And I'm gonna narrow the time span here to 6 o'clock. And you can see that I've been stuck at about 80.6 degrees the whole time. This isn't a super fine-grained temperature sensor, but you can see that I've been stuck there at 80.6, and at least for the time that we've been publishing to the cloud. We've seen other temperatures go by, of course, but those weren't being published to the cloud. If I look at humidity, I won't even drill in this time. You can see the humidity has been constant at 45, which is consistent with what you see being reported here in the console that is my SSH session into the Raspberry Pi. Okay, so pretty straightforward. The third thing that we're doing, in addition to doing these two property publishes, remember that I said that tell it when you're modeling a thing, you can have enumerations. I have an enumeration for this particular thing which says, is the state normal or high for the temperature? And it just corresponds to whether I've crossed the threshold. So if I'm above the threshold, then I say, hey, the state is high. And if I'm below the threshold, the state is normal. So because I'm doing this alarm publish, which again is just, if you were to go look and say, well, what is an alarm publish really? It's just a chunk of JSON that corresponds to what their backend is expecting. In this case, a command alarm.publish with a thing key and a property and a value. But that's what's causing this to appear here, where it says, hey, the temperature state is high. Okay? And if this were to cool down a little bit in here, it feels like this is the new normal for temperature. So it's not going to go back to normal. But you'll see how we can change that in a second. It's my own good segue. Let's talk about that. So we walk through the control loop here, kind of with our primary flow. There's one thing here that when we called MQTT Connect, we also said, hey, I want to register a callback in case the broker calls me, in case the broker publishes a message that I'm subscribed to. And it so happens that the way this guy works when I connect is that he's, in addition to connecting, he subscribes to some notification topics that the IoT backend is offering, okay? And when messages come in to those notification topics that this guy is now subscribed to, I want to be able to deal with those. And in particular, there are two interesting things I care about. Remember I said that in Tellet's IoT backend it was possible to define methods. So I have a method here called set threshold temperature, and I have another method called set action message, okay? If you were using Amazon's IoT backend, then you'd probably have to say that there would be a threshold temperature property, and by convention, the device wouldn't write to that. People controlling the device would write to that. But it would just be totally a handshake you'd come up with, right? You'd just say, well, okay, I got some properties that the device isn't going to write to. They're there as control levers for other people to write to. Not as clean in my mind, but that's what they would do. Here you have the ability to define formal methods against the thing. So let's go ahead and try this. I've got this thing. I've got set threshold temperature, set action message. All I'm doing in response to those is changing my threshold temperature within my class, my monitor, and then I'm acknowledging the message, or I'm changing my action message. So let's go ahead and since our new normal seems to be 80.6, let's change the threshold temperature to 81 and see if we can get this display to go green with the green LED. And the way I'm going to do that right this second is I'm going to go over to a thing that Tellet offers in their developer console. I'm going to go to the API tester. I'm going to go to my eyes aren't seeing it. There it is. The screen change layout with the reduced resolution that we're using here. I'm used to seeing it on the top row. So you can see the bit of JSON here that is going to allow this to happen. So I'm just going to plug in RASP IoT-1, set threshold temp, and the parameter is called threshold temp, and I'm going to make the value 81, right? So let's go ahead and test that out. Can you guys see that okay? Okay.
Yeah, I meant we couldn't see the device. I don't know.
Oh, you can't see the device, yes, there we go, okay. So it, you can see that in my SSH session, got that, great, now my device is back to green because now the threshold temperature has been raised a degree, so I'm out of squawk mode. Any questions on that? You'll see that more when we get to the mobile application, but I just wanted to show, even before we got to the mobile application, I just wanted to show that this device, now that it's cloud connected, is using MQTT not only to report state up, but also to offer some ability to control it remotely back down through MQTT. So it's publishing MQTT messages to a topic that the server is subscribed to, but it's also subscribed to some notification topics so that when someone tries to invoke some actions against it, it can find out about that and take action. Yeah. Any questions about that? All right, let's keep going. So that's the kind of the cloud version. So now we have this device that, hey, it just used to be a simple temperature monitor with just local visibility into what was going on. We added cloud connectivity. Now, heck, I can walk up to this guy and over time I can, back to here, let me just do the, at the very least, okay, and it says it's too hot, right? You can see that there, okay? And then if I refresh this screen, you can see that this state is now high, and maybe the more interesting graph now at this point is the humidity graph, which I'll just, you can see there that I caused a little spike in humidity and then it came back down. So I have kind of a nice view of this data that without even really doing anything, I can just kind of drill in and see this. If I was using Amazon's IoT platform, I would probably shunt all the data into something like Kibana or some other sort of visualization tool. They don't give you a visualization tool out of the box, but they would point you at other pieces in their ecosystem.
How much history is the storage?
That's configured. It's configurable. You can. I think by default it's like 90 days, but it's it's whatever you want to, kind of what you want to pay for, frankly. Okay, so now that we have shown that off, we went from a simple device to a connected device. Now we're going to do a mobile companion app. That's actually my last slide. So let's talk about Xamarin. You guys probably like, you've been talking a long time and you haven't said Xamarin. Now that it's 7:27, let's roll with the Xamarin, shall we? Okay, so get these notes up here. So I mentioned that the Eclipse Power project is the place to get clients. One challenge is that the C# client, let me just show you here because pictures speak louder here. This is check-in frequency for the Python client. You can see that's been pretty good. All right, people that's pretty active. Check-in frequency for the Java MQTT project, that's pretty good. Check-in frequency for the JavaScript MQTT project, pretty good. You know where I'm going, right?
Yeah.
The C# project has been struggling here. So it's a little out of date. There's some things that aren't quite working. It doesn't support, I shouldn't say that. It doesn't support tunneling over WebSockets, which would be nice to have in a big way, so you get past that firewall issue. And its portable project, it has an iOS project and an Android project and a portable project, but it doesn't seem to quite work out. And it could be that there's brighter folks than I in the room that would figure it all out in no time.
What do you mean it doesn't quite work out?
Well, it doesn't quite work out in that, well, the first issue you run into is that its portable project uses a different pickle profile than Xamarin uses by default. It uses pickle profile 259, which doesn't seem like, okay, well, I can probably just, it seems like it works out to just change the generated Xamarin portable project to pickle 259. Do other people do that regularly? Do people use 259 often? I don't know, we've always just used 78, we've always just used the default one. But you're missing, regardless of profile, you're missing everything in the system.security.cryptography.x509 certificates namespace. Turns out you kind of need that if you're going to use any kind of advanced security features with MQTT or even any garden variety ones. You kind of need that stuff. So what I have wound up doing is two things. One, bringing the project down locally rather than consuming it through a NuGet package. And two, putting all of my MQTT interaction in classes that I drop into my Xamarin iOS project and then link over into my Android project. You could do this, you gotta pull the same thing off just by having a shared DLL, a shared project, right? So essentially that's what I'm doing, it's probably a better way of saying it, is that I have a shared project for dealing with MQTT stuff because the portable project does not seem to be working out at the moment.
Is it a licensing glitch? Or
Say it again.
is it a licensing glitch?
Not that I know of, I mean, it's not.
Well, so you're looking at the state, when you were saying when it was last active, could it be that it was before the Microsoft buyout?
Oh, well, this, I mean, this is a licensing issue. I mean, this project is just another open source project under the Eclipse.
No, I
banner.
get, but when was the last time it got significant love?
Oh, it looks like back in December of 2015.
Months,
Yeah.
recent enough, but it could have been started prior to the buyout. And then
Yeah, I don't know, and like I say, maybe the Windows IoT project will inject some new life into a C# MQTT implementation. But I don't want to give the impression that it doesn't work, because it does.
No.
But it's not going to be just, hey, right click on my portable project, add the portable MQTT reference, likewise with iOS and Android, I'm done. At least what I've had to do is bring it down locally and consume it a little differently. In fact, I wouldn't even need to have the portable one in my solution because I'm not using it. So let's walk through how I've structured this. I've got an interface called MQTT Demo Service Client that is exposing a connect operation. It's exposing an event so that people who are consuming this class can find out about interesting things that are arriving in this mobile app over MQTT. And then I'm exposing two methods, set threshold temperature and set action message. This is the interface that I consume over my portable library inside of Xamarin.Forms. So the implementation is sitting inside of the shared project that is not a pickle, and the interface is here in the portable project. Does that make sense? That's the way you guys always structure things when you've got. Well, the wrinkle is the fact that in theory there's really nothing about MQTT that shouldn't be able to live in a pickle, but that's the way this is. So we've got this interface defined. The event handler is exposing something called MQTT demo event args, which itself is referencing this class with a nullable for each thing that I care about, a nullable for temperature, a nullable for humidity, and then obviously a nullable string for temperature state, whether it's high or normal. And the reason I do that is because the data is going to arrive sparsely. So like you're going to hear about a change in temperature, or a change in humidity, or a change in state, but they're not all going to come at once. And so I've found this pattern useful in those situations where you just say, all right, go ahead and publish an event that has a structure that's sparsely populated. You might have a different pattern that you like, but that's why I've done this here. So I've got the interface. Then I have a base class so that interface is inherited by my actual service client that is living over in the non-pickle project. But that derived class also derives from what I call base MQTT service client. That guy doesn't have very many jobs at all. He's basically, he exposes a virtual connect method where you give it the key of the thing that you're trying to manage. In this case, it would be RASP IoT-1. You saw that go by earlier. He creates the MQTT client itself, specifying a broker address and a port, and then he actually connects to the broker, and then it sets up the subscriptions. Now, in this case, I am subscribing to a series of topics related to property changes on the device. So property /plus. Remember I told you that there's wildcards and topics when you subscribe. Plus is a single little wildcard. So I'm going to hear about changes to temperature on this guy and humidity on this guy, because that's the two he exposes. And then I'm also going to hear about changes in the alarm state, the high normal thing that I showed you about. So I set up those 3 subscriptions using subscribe, and then I'm done. So I've connected to the broker, I've indicated what I want to subscribe to, and I'm basically set at that point. The rest of these methods are really just for decoding the byte stream. They're just helpers for decoding the byte streams that come back from MQTT. Any questions on that? Pretty straightforward. So then the derived class, which you would maybe have for each kind of thing you're trying to manage, because this is where we get into to the specifics of a particular device. Like I've got, I'm expecting now down at this level to be able to expose things like humidity and temperature and that kind of thing. So I call the base class connect method, and then I register for a callback when anything comes in over a subscription. So this on published message received. And that guy, he basically is translating the raw messages into a strongly typed event that we can fire off to Xamarin.Forms or some other UI. And so here I'm basically saying, if it's temperature, then let's go ahead and assign temperature to the message, to the payload of the message. If it's humidity, go ahead and extract humidity from the payload of the message. And if it's temperature state, go ahead and extract that. So I'm basically saying, based on the topic of the message that was published to me, make some assumptions about what the payload is, and go ahead and set up the data structure to reflect that payload, so I can publish it off to my UI.
So in your case, the topic has temperature and humidity, and you're determining, versus just broadcasting out every 2 seconds, here's the temperature, here's the humidity.
Right. The assumption is that those things might be changing at different rates. So that's we are getting a message inbound for one for temperature, one for humidity, one for state
And
changes.
what if nothing changes for an hour?
Then you wouldn't hear anything.
No published at all.
This application, now there's an underlying heartbeat message that is happening down in the plumbing to make sure that clients haven't just gone away.
Yeah.
But in terms of callbacks to this method up here in kind of application land, you just wouldn't hear about anything. So the topic name looks like this, thing slash something key like rasp IoT1 slash property slash temp. I'm sort of cheating and using path.getFilename to extract the last part of that because it looks like a path. And so my property name in this case would be temp. So I would fall through this case statement and say, okay, I'm going to extract a float from the binary message content, and so that I can pass that along to my UI. Does that make sense?
So you're purposely keeping these very discrete. Is it a bad case to combine temp, humidity in one call?
Well, the way that I set up my subscriptions. So when I subscribed, I basically said I want to subscribe to every individual property change. Now, it turns out that the Tell It IoT backend does not have a way of saying, I want to subscribe to changes in this object, and please deliver me everything when it changes. It assumes that you probably don't want to do that because that's wasteful on the wire. So it doesn't give you that. Amazon's world is the same, actually. You can only subscribe to deltas. You can't, so the way that both Tell It and Amazon work is if you want the whole state, you have to ask for it. You'd have to publish a message that said, hey, please send me the whole state of the object. And that would be on demand, essentially. It wouldn't just happen regularly. So neither platform offers the ability to get a regularly delivered message of the complete state of the object. They're always sending you deltas.
It's a really expensive thing to do.
What's that?
It's a really expensive thing to do. I can see where Amazon with the scale they're at didn't want to do it.
Yeah.
It's like a brute force DOS across the.
So once I've populated either temperature or humidity or this state, I go ahead and publish this message I go ahead and invoke the event handler. And this guy is exposing an event handler that UI or whatnot can hook into. So let's look at that UI. Really, this was not intended to be a Xamarin.Forms wow fest by any means. All I've got here is a really simple table where I'm going to show the properties. I'm going to show the state, whether it's high or normal, and then I'm going to offer the ability to do to do some remote interaction, to reach out and set the temperature threshold like we saw before, as well as set the action message that's going to appear when we get over temperature. So we'll demo both those things here in a second. So I've just got a basic table view that does that, and then the only other thing that's in this particular page class is using the dependency service to resolve that interface and issuing the connect. So, and I did this in on-appearing, and normally this is the kind of thing, I don't usually use the dependency service, usually use something like tiny IOC or whatnot, and we would just do constructor injection. But to keep this simple, we're going ahead and using the dependency service here. And when we issue our initial, after we connect, we're registering for an event for when new messages are received. And then really all we have here, when the message is received, the message could be received on any thread, because obviously it's certainly not going to be the UI thread. So we do a begin invoke on main thread so that we can touch the UI safely, right? You can't touch the UI off the UI thread. So I do a begin invoke on main thread, and then I say, hey, for any one of these things that happens to have a value, because they're all nullable, I'm going to go ahead and set the value of the corresponding cell to what it is that arrived, right? And then finally, I've got the ability to set my threshold temperature and my action messages. Those are really cheesy. Let me just show you what those look like. Normally, when I'm doing this kind of thing, we've set up some strongly typed classes that represent that that represent those operations that we then use like JSON.NET to deserialize. But for sake of brevity here, I'm just using a string template to call set threshold temperature or to call set action message, and we're just jamming our parameters in there with a string.format. Pretty straightforward. That's all there is. Let's see what it looks like. Okay, so you can see, actually you can't, but I'm going to make it so you can. Drag this over here. So you can see that this guy is reporting 80.6, humidity 44. I'll go over here and do the breathing trick again. Change to high, you can see my temperature and my humidity track right along with that. And it's pretty much instantaneous. There's really no delay. It's really very, very low latency. So let's try some other things. Let's go ahead and change my threshold temperature to 85 degrees. I'm going to click change threshold here. If I go back over to my SSH session, it takes this guy, the Python code isn't really set up to look for method invocations all that often, so it takes just another second for that to come through. But you can see now I'm green, my state over here is normal because the new threshold is 85, okay? I can also set new action message, do that. I'm going to drop my threshold temperature. Let's see if that takes first. Okay, so I've set my new threshold message, or my new action message, I should say. I'm also going to lower my threshold temperature. Just press the button twice. Okay, my new threshold temperature is 79. So now I'm green. Oh, wait a minute. That's my, oh, okay, all right, there we go. There we go. Okay, so now my state is high, and my message changed there from the default message over to the message that got requested. So what you're seeing is that pretty darn straightforward to add MQTT support to the Xamarin.Forms application. Despite the condition the library is in, it is workable. I'd like to see the library support WebSockets so that you could do this in any kind of a corporate environment as well. So hopefully that'll happen soon, or maybe one of us will step into that project and help with that. But it does work. It allows me to connect to the broker. I get a pretty real-time, I don't know if you just saw it transition to 80.6, but the reflection back to the mobile app is pretty much instantaneous for both state change, for all of these property changes and state changes. But then I can also have the device expose remote operations that it's pretty easy to route back through to the broker and back down to the device. So it comes together pretty nicely. So that's it. That's kind of what I wanted to show you. I wanted to show you just the idea that we can start with a real simple connected device like this, that looks like you might have gotten the B- from your 8th grade science fair because it's for messiness, right? But we start with a simple device. It's got a real simple control loop. Then we added cloud connectivity. We saw what that looked like up in the cloud in terms of being able to visualize the data. But then that back end isn't just for visualization. It's itself a development platform that exposes MQTT, and we can reach up and wire that into a Xamarin.Forms app pretty easily. Any questions at all? Yes, sir.
Have you looked at any other alternative protocols?
Most MQTT backends support HTTP, HTTPS, MQTT, and MQTT over TLS, and then they'll support MQTT over WebSockets. Some will support a few additional protocols like CoAP and a few others that are maybe competitive to MQTT. I have not dived into those at all. So I don't, if they're, I haven't looked into other protocol like CoAP and protocols like that. I don't believe are about broker, publish, subscribe. So I think that if you find that metaphor interesting, I think MQTT is the one to use.
Do these have like developer sandboxes to get going on without having to pay?
Yes, that's what I'm actually using here is just a free account with MQTT, or excuse me, with Eclipse.org offers a m2m.eclipse.org is just a broker. There's no actual back end there. It's purely a broker. So it would be, but you can publish and subscribe to it, but it doesn't offer any semantics above and beyond that. But there are lots of sort of IoT backends, including Amazon, that there's a free tier where you can start playing.
Running on my own laptop type.
Absolutely, yeah. Mosquito was the name of one such. There's a lot. Yeah.
Is there anything in Azure, or is that just the Windows 10?
Azure has its own IoT backend. I have not played with that at all, but that's another whole world you bet. Yes?
I'm just curious if off the top of your head you knew what sensors you have, like BHATA or something, what the sensors are? Because I know you have RGB LEDs, you've got red, green, and blue in the LED. But do you know offhand, what sensors you have?
I can only tell you that they are the sensors that came with the Grove Pi kit I purchased, and I know that I've got a digital temperature and humidity sensor here, but I don't know offhand what their implementation is.
Did you get it from Medical?
I don't recall offhand, but I know you can buy that that basic Grove Pi shield with the sensor kit. You can get that from Adafruit or Amazon or from any of those, right from Dexter Industries.
Dexter has got the Grove Pi kit, and
Yes.
then you have the robots.
Yeah, yes.
Plus they just reused the new spinny hat that they put up on Mr. Shuttle for the IS.
Huh.
I'm spacing the name of it now, but it's got all the environmental stuff built into the hat for shield.
Interesting. Other questions?
Looks like once you pick a vendor, you're with them. I mean, a lot of your code is going to be very dependent on what they do and
Yes.
how they do it.
Yeah, I would agree with that. And then I think, and it kind of stands to, by the time you have kind of the full set of semantics for implementing something meaningful, it kind of makes sense, right? So yeah, I think in the same way that, if you decide you're going to commit to a document database or a relational database, you're going to get far enough down the path where, so this is really no different. By the time you get pretty well embedded into an IoT backend, you'd probably be with them for a while.
How come you chose to write the Raspberry Pi client piece on Python rather than using IoT or Tellits?
So Tellit doesn't have a, are you talking about their asset gateway tool?
Yeah.
Oh, so you're a Tellit guy, okay. So Tellit offers a runtime that runs down on Linux, on Windows, on Raspberry Pis, on gateways, and they call it the device-wise gateway, and it's a visual environment for doing the kinds of things that we were doing in this Python code. And I had actually thought about that and would still like to try it, but there's what that visual environment requires is a driver for the sensor set that you're working with that will expose the shield and the sensors to the visual environment, and they don't have a good one for the Grove hat, for the Grove Pi piece.
Are there Lua plugins for that?
I don't know. I would kind of be nice if they would just support Python in that environment, because then you'd have kind of a better escape hatch. But so yeah, one of the things you'll see for writing intelligence down at the edge is a whole variety of visual environments, whether it's Tellet's ASIC gateway or IBM's Node-RED, or there are a set of environments that people are using for doing even lighter weight scripting of the edge logic than Python code. Yeah.
On your contract byte where 0 was no contract, 1 was at least once, the 1, 2 is at most once.
The quality of service levels?
Quality of service.
Yes, yeah.
So that implies to me, and this, tell me if this is right or wrong, it surprises me, that there's an ability to queue up if the subscriber goes away for a long time, like maybe an hour or a year.
There
That makes
is.
me wonder, does it just
Yeah, there is this
queue
notion
forever?
of, in some brokers, let me just get to that slide here. There is a notion in some brokers where if you use what's called a persistent session, bullet 3 here, if you connect and say, hey, I want a persistent session, if you were to get disconnected and then reconnect later with a persistent session, you would have all of your missed QoS 1 and 2 messages delivered to you. Now, you can imagine that for a broker to implement that, they better have some sort of queuing implementation themselves, right? That, and so, given that the origins of where this protocol came from, you can imagine how that worked. But yes, that's a pretty big promise to make. I haven't built anything that has relied on that behavior. I haven't actually, neither Amazon's broker, I don't actually know about Tellet's broker, but Amazon's broker doesn't support that, doesn't support QoS 2 at all, and it doesn't support that aspect of QoS 1, it doesn't support persistent sessions.
The quality is preserved by the broker, the middleman.
Yes.
Okay.
Yes, absolutely. Now, the publisher and the subscriber have to indicate what QoS they want, but yeah, it's really the broker that's doing the work to make that happen.
Okay. Thanks.
Any other questions? Thank you. Thanks much. Thanks for coming tonight.